said, I'm Bob Lane. I'm Division Equipment Maintenance Manager for Dalwell Schlumberger in the Mid-Continent Division. I've got quite a few slides here that I want to show you, and we're going to talk about quite a few different things in the course of this discussion today. So I would like for y'all to know that if you see something or see a slide, an overhead, or if I say something you'd like to know a little more about and want to ask a question, feel free to do that, okay? So I guess I'd like to start. Is there anyone here that knows who Dalwell or Dalwell Schlumberger is? You ever heard of him before? Okay, where did you hear about Dalwell?
Dean used to work for him, didn't he?
Beg your pardon, say?
Okay. He used to work for him.
I think so.
Okay, Jerry did. I believe Jerry works in Commerce City, Colorado, if I'm not mistaken. Well, we are an oil field service company, and basically what we do and what we are we're a worldwide oil field service company that is a 50-50 venture. One half of it is owned by Schlumberger, and the other half is owned by Dow Chemical. That's a very unusual arrangement, to say the least, because usually it goes 49-51, right? Why would it do that? Why would it go 49-51?
Give someone the control of use.
Right. Somebody has control. This organization here is 50-50. Schlumberger owns half, and Dow Chemical owns the other half. We are Schlumberger managed, but there are a lot of Dow Chemical managers in that program also. Will it mess you up if I turn that light up? Okay, so we're a worldwide oil field service company. We're 50-50 owned, half Dow Chemical, half Schlumberger. We provide service to the oil field industry such as cementing, fracturing, acidizing. I might make a note here that Dow Chemical, under what they used to call DOW, WELL, acidized the first oil well in 1932 in Mount Pleasant, Michigan. Dow Chemical was a chemical company in the Northeast, a very strong one, and acid was a byproduct that they could not get rid of. So it was junk, and they had nothing to do with it. And someone got the idea to see if they couldn't dispose of this acid in an oil well. So they took a 55-gallon drum of acid, some stuff that we call an inhibitor that kept the acid from eating the barrel up, and about 30 foot of garden hose. And they dumped that acid down the oil well. And production on that oil well went from like 1.5 barrels a day to 12 barrels a day the first day. And the second day, like about 20 barrels a day. So needless to say, they stumbled on a gold mine. We also are in coil tubing and nitrogen business. NAM, or North American Operations, employs approximately 1,800 people in the United States and Canada. There's 85 districts, divisions, or sales locations in North America. And about 47 of those locations actually have service points where we actually perform service at the well site. So basically in North America, this is what we look like. We're broken up into 8 operating divisions. The Northern Division is officed out of Anchorage, Alaska, and it covers Alaska and Canada. The Western Division is officed out of Commerce City, Colorado, which is an outpost of Denver. The Mid-Continent Division is officed out of El Reno, Oklahoma. West Texas out of Midland, Texas. South Texas out of Laredo. Gulf Coast out of New Orleans. The Southeast Division out of Longview. And the Eastern Division out of Charleston, West Virginia. In the Mid-Continent Division, which is the area I'm responsible for, is like the map. It entails Kansas, the Texas Panhandle, all of Oklahoma, and eastern Arkansas, western Arkansas. So we have districts in those respective areas. And again, they answer to management in El Reno, Oklahoma. So there they are. The Mid-Continent area has six districts. Ulysses, Kansas, which is in southwest Kansas. Perkin, Texas, which is in the north Texas Panhandle. El Reno, about 20 miles west of Oklahoma City. Enid, which is straight north of El Reno, about 80 miles. Fort Smith, Arkansas, is just across the border into Arkansas. And Elk City, Oklahoma, which is in western Oklahoma. Okay, now I'm going to turn this off and I'm going to turn the light back on, and I'd like to give you a little bit of an idea about what we do. So a lot of you may not be familiar with oil well production, how it all happens. Is there anyone here that really is? Have any of you guys really worked in the oil field industry? And what did you do?
Roused about it.
Okay, so you've seen a lot of it. But basically, everyone has the idea, or a lot of people have the idea, that you poke a hole in the ground, you put some pipe in the hole, and the oil comes gushing out. That's the way they did it on TV, right? But it didn't like that, believe me. There's a tremendous amount of money involved in drilling an oil well. Certainly, before the drilling rig ever shows up, there's a lot of things that happen that we won't really even discuss. But if this is the surface level, this well may be anywhere from 3,000 to 25,000 feet deep. So basically, the first thing they do, they start drilling, and they drill a hole in the ground. They drill so far, and then they put pipe in the hole, what we call casing. So the casing has to be cemented in place to protect the water formations. So what will really happen, they'll come in here, drill a hole so deep, and put like a string of casing in the hole that may be 13 3/8 casing. We have to cement that casing in the hole. So what we actually do is we pump down that casing, and so far that's as deep as the pipe will go. So we bring cement plumb back to the surface. Therefore we call that a surface job. That's the first cement job that happens on a well. It takes some real technical equipment to do this, and you'll see some of it a little later in the presentation. So we start pumping down here, and we pump the cement until we get cement back to the surface. Then we know without a shadow of a doubt the formation, the annulus we call it, is completely full of cement, and the pipe is cemented in the hole. Then the drilling rig resumes, drills another maybe 5,000, 10,000 feet. We do the same thing. He'll go ahead and he'll put some pipe in the hole. We'll come back and we'll pump cement back in there again. Now, we won't bring cement back to the surface at that time because you can't do it. It's impossible. But this may happen 3 to 4 times in the course of drilling a well. Now, once the bottom string of pipe is in the hole, we call it the production string. That's actually the last string of pipe, and they're going to actually produce the formation through that pipe. Once that's in the hole and cemented, we go in there and we perforate, because the oil don't just come flowing in like a maniac. And needless to say, there's also pipe in the hole that does not have holes in it. So there's no way for the oil to get in there anyway. So if this was the pay zone right here, they'll perforate this whole area. They may shoot 130 holes in that casing. So what will happen then, the oil that's present right at the well bore would flow into those holes and you could pump it out. The problem with that is that's very little of what that pay zone actually entails, because it may go out here for a half a mile. So what happens next is someone like Dowell or Halliburton or Western Company or BJ will come in here and do an acid job on this. And that acid job, they'll go down here like a couple of days before, and they'll pump acid down there that's anywhere from 7.5% to 28%. The acid is inhibited, so it doesn't eat the pipe up, and then it's also flushed, So there's no acid standing in the pipe above this level, above the top perforation. Now they'll let that acid usually work for a couple of days, and then they'll go in and frac it. And what we actually do when we fracture is, does anyone know what do you do when you fracture your elbow?
Right?
That's right, you break it. So what we're really going to do, we're going to fracture this formation. So, and actually those cracks will migrate out from the well bores, in some cases 300, 400, 500 yards long ways. There's a tremendous amount of pressure just from the overburden, the weight of the earth on top of all of this. So when you crack that formation, it don't crack like this. It cracks like this. How they know that, I don't know. I've never been down there, and I hope I never get down there. But anyway, to make a long story short, once you open that formation up, if you don't do something to hold it open, what's it going to do? The overburden and just make it go right back closed. So you can take a tremendous amount of horsepower and a lot of fluid and pump it down this hole at a lot of pressure and crack that formation, but it will not stay open. So you have to prop it open. And what we mean by that, we actually put a proppant like frac sand or intermediate prop, bauxite, some real hard materials. Depending on how much the pressure is, sand won't hold it open, it'll just crush it and then packs off and the oil won't flow through it anyway. So you've got to have porosity for the oil to flow down the fractures into the wellbore. And that happens through fracturing. So basically, that's what we do. We cement, acidize, frac, and then also you notice coil tubing and nitrogen. A lot of times if you frac a job and it doesn't go to completion, you'll wind up with a tremendous amount of feet of pipe that have sand left in it. So we'll go down there with a string of coil tubing, and I'll show you a picture of one of those rigs, and start pumping nitrogen, and it breaks the sand all loose and circulates it back to the surface. So you can run your coil tubing plumb to the bottom of the well and clean out the production stream. Any questions up to this point? You guys got questions, be sure you feel free to ask. Okay, we're going to move on here a little bit then. I'm going to tell you a little bit about the oil field industry. What we're looking at here is 2 years of data. There's actually 3 different lines on this graph. One of them is Petroleum Institute line, which is the dotted line. The other one is Baker Hughes drilling report, which is the dark solid line. And the thin solid line is 1991 Baker Hughes. There's quite a difference in 1992 dotted line and solid line because the PI report includes all rigs, where the Baker Hughes report, which is this line, only includes wells below 3,000 feet. So there's a lot of shallow well work that's less than 3,000 feet. So that may be a drilling rig that's not counted on the Baker Hughes report. So that's the difference in these 2 lines, okay? If you look at these lines, this being 1992 and this being 1991, it's pretty obvious that the drilling activity in our division has been basically flat outside of this dip right here. So you draw a line plumb across that 8 months, there's pretty much an average can be about 114 rigs. So it's down probably 20-some, 25 rigs from 1991, but it is flat. Historically, we end the year where we started, which only makes sense. So if that continues to be true, and we were at 125 rigs there, and we're about 118 or 119 there, 114, we're going to be basically flat all the way through the year. And that's actually what we budgeted to have. We anticipated that that's what was happening, and it looks like we were right. Some of the things that are kind of alarming, you guys are old enough that you probably remember some of what happened in 1982. In the state of Oklahoma in 1982, there were 1,400 1,400 rigs running in Oklahoma. There's only 114 today. In 1982, in fact, in North America today, there's only about 900 rigs running. So you can see what a dramatic situation is taking place in the oil field industry. But it isn't all gloom and doom. It sounds like it is, but it's not. Because like I say, this is relatively stable. The state of Oklahoma, or the Mid-Continent Division, has been running from 85 to 120 rigs for the last 7 or 8 years. So we have every reason to believe that that's going to stay pretty consistent. And any major change in the oil field in the world today could affect what happens in Oklahoma. You all seen what happened to the price of oil when the Persian Gulf War started. It went from like $14.50 a barrel to over $30 a barrel. That same thing could happen again. So, and that's not what we want, but I really do believe this country does need to become more self-supporting in the petroleum industry. Talk a little bit about BS shops in the area I'm responsible for. They average from 3 to 4 bays. 2 of those are usually work bays, and one of them is a service pit and maybe a wash bay. Every district has at least 1 wash bay, and some of them have 2. We, in our area, we have all the equipment it takes to do stimulation, cementing, nitrogen, and coil tubing. We average 1 to 3 shifts, although right now, for the most part, most districts are running 1 shift. We do the bigger percentage of our major maintenance during daylight hours. When we run 2 shifts, we try to do most of our preventative inspections on the evening shifts. The responsibilities in addition to that a maintenance person has, excuse me, every district has a forklift, at least 1, maybe 2. There's a lot of centrifugal pumps in our operation that we maintain. We've got a lot of high pressure air compressors, meaning like WHQ, Labco compressors that produce 600-700 cubic feet of air a minute at 30 psi. And we've got a lot of low type blowers or vane type compressors. So maintenance personnel also maintain those units. A little bit about what we expect from you before we hire you. BS Central Division goal is to be 80% degreed, and you guys will be degreed people when you get out of here. So we're looking for associate degree people, mechanical engineers, electrical engineers. We hire quite a few electronics technicians, which are also associate degree people. We require that you have a high school diploma or equivalent, a 3-year associate degree or equivalent. We occasionally do hire someone off the street from another company or someone that has 3 to 5 years experience. You've got to have a clean driving record. That means no DUIs, no DWIs, and no more than 3 moving violations in the last 3 years. That's pretty strong, but it's pretty much the standard with the industry today. When we address an entry-level group, a brand new group at OSU that's just starting the first of their 6 trimesters, he's got 3 years, 2 to 3 years to solve this problem. That's not the case with you guys. You know, if you've got a driving record problem, it will show up in your application and also in your driver's test. So one thing I try to tell them in every case is, you've got a driving problem now. Now is the time to start working on it, because you can't do it when I'm sitting here interviewing you and you're in your last trimester. It's too late. There's nothing you can do about it. But you can when you first start. We must be drug-free, and we do conduct drug tests on every new hire. You've got to be able to pass a DOT physical. And with the new CDL requirements, it's usually going to be also a requirement that you have a CDL. It's almost impossible to road check a truck even today, especially if you're on an interstate highway, if you don't have a CDL, even if you're a mechanic. So we've kind of decided we're just going to go ahead and bite that bullet, and that's going to be part of the requirements. You must be 20 years old, although you cannot get a CDL at 20, but we'll hire you at 20, because that's all going to be in the mail. You can't?
I got my CDL 18.
For driving across that line?
You just can't, you can't go out of your interstate.
Yeah.
You're interstate till you're 21. But I can drive in.
Very good, okay? And then you've got to accept 24-hour call. Even I'm on 24-hour call. Talk a little bit here about entry-level duties. So if we hired you today, this is more or less what we would be expecting you to do. You'll be conducting STEM 2 and STEM 3 inspections, and that does include equipment service. You'll go to Kellyville for 2 weeks within the first 6 months of your employment. You've got a personal safety responsibility. I know that y'all are getting some safety training here. We provide the equipment, but you, more than anyone else, are responsible for your own safety attitude and performance. We have a merit review program, and we actually consider safety performance in part of that review. So if you've broke your leg twice and bent the fender on a truck, you're probably not going to get a raise. You'll assist Mechanic 1 and above on major maintenance tasks. If we pull a 3512 Cat engine off the deck or something, you'll probably be helping someone do that. After you've gone to Kellyville, occasionally you will drive and operate support equipment. You will, when you become properly trained, be required to make service calls on the units that are down. And we have another job that we call location mechanic, where I'll show you some pictures here in a while, but we've got, $4 or $5 million worth of equipment on location, and the customer's well, he's got $3 to $4 million tied up in also. So there's tremendous responsibility to perform after you get the location, meaning DS. And so on high-level jobs, we'll have mechanics out there occasionally. And then all levels of maintenance personnel are responsible for shop and shop equipment image program. Does anyone know what that means? What's a shop image program? They'd say it might even have something to do with the brand.
Keep it clean.
The best person in the world to clean a mess up is the one that made it. Because more likely than not, that's going to have some bearing on how big the mess is next time. So that's the way we do it. Usually at some point in each day, and maybe to a major extent on a Saturday morning, we may do a lot of shop cleaning responsibilities. A lot of the equipment we have, we've run a lot of international harvesters, freight liners, GMCs, Peterbilts, Fords, and Kenworths. The bigger percentage, probably today, 50% of our equipment is international harvesters. We haven't bought a lot of equipment in the last 5 years, so at one point in time we were almost 100% international harvester. We found that when International Harvester had some problems with the union, the strikes and all that, and they couldn't provide equipment, we seen a very definite need to buy some other trucks. We bought a lot of Fords and GMCs during that time. And we bought another company and wound up with a lot of Kenworths and freight liners. And most all of the new equipment we bought in the last 2 years have been Peterbilts. Engines, we run a lot of Detroit series, all of 53s, 71s, 92s, and 149s. We run a lot of Cat 3208s, 3412s. We still have a few D348s. We've got quite a few 3512s, and all of our new tractors have 3176 engines. Are y'all familiar with that engine at all? Okay, then we have a few Cummins 350s, a select few. We've got quite a few 3600 kTA Cummins engines, and I don't know that we have any 2300 series. We got quite a few small air cooled engines like Gorman, Asteroids, Wisconsin, and Lister that we'll use to drive a small centrifugal pump or drive an air compressor or something of that nature. Got all of our standard transmissions are Fuller, and all of our automatics are Allisons, except a few Labcos. So we've got a lot of 650, 750, 60, 61s, 8 and 9,000 Allisons. And like I say, we do have some of the 8-speed twin disc transmissions, the huge ones like y'all may have seen in an earth mover. Then we're running Rockwell Eaton and IHC differentials. Our power ends, if you know what I'm talking about, a lot of them are OPI, most of them we build ourselves, but a lot of them are OPI, Gardner, Denver, and Fuji equipped. Okay, any questions up to this point? Now's a real good time if you got any. Well, you guys are going to get a lot of help. I can see this right off the bat. Okay. Kind of give you an idea about what's involved. Is it hard if I take my coat off? Like I say, kind of give you an idea about what's involved here. This is a typical small frac job. So on this job, we've got 3 frac pumps. We've got what we call a missile. There's a blender setting here that you cannot see. There's a nitrogen pump right there. And that's a tractor that probably hauled this missile out here. This unit right here costs about $450,000. With a tractor under it, it's over $500,000. The blender that you can't see costs about $380,000. This missile, simple as it seems, all this treating iron has 15,000 PSI capabilities. Costs a lot of money. That thing, just like it said, probably cost $120,000. And an average tractor costs about $85,000 to $90,000. That nitrogen pump right there costs probably $400,000. So needless to say, there's a lot of money tied up in our equipment, and the customer has a lot of money tied up in his well. So there's a definite need for everything we do to do right. That's part of the reason that we talked about hiring 80% degree people to perform these duties. You guys have demonstrated a pretty deep desire to say something more than I just want to be a mechanic. You know, you could have probably walked out of high school and done that. I think you'll find that your level of advancement and everything will be far accelerated because of the decision you make. By the same token, we sincerely hope the job you might be maintaining this unit is also considered with that. Like I said, so basically that's a small frac job. That job right there, the customer would probably sign a service receipt for $85,000 for that job at the most, if even the most complicated one that size. So what do you think about this? Things have become considerably more complicated. That is the largest frac job that's ever been performed in the world today. Yeah, well, Schlumberger did it, and they did it in Laredo, Texas. Some of the things that you might want to take in mind, we talked about 3 frac pumps on that other. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 18 frac pumps there at $500,000 a piece. That's more money than you and I make in a year.
Probably a lifetime.
This is what we call a sand chief. That unit right there holds 400,000 pounds of sand. There's a few of them on here that are smaller, like that one. So if we just kind of kick that out and said and the small one holds 270,000, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sand sheets on that job. So if you took, say, 300,000 times that, you're going to see how much sand that is. And believe you me, that's a lot of sand. Does anyone know how much that square tank right there holds? Where's the roustabout? You know how much that tank holds? It holds 500 barrels. We counted those things a while ago, and I think there's like 85 or 90 tanks there. So we didn't just go out here and set up on this job at 7 o'clock this morning and pump it and then go home the same day. We probably came out here 1 to 2 days early. There was a lot of blending that had to take place before the job could ever start, that took place and was pumped back into those tanks. Then we'll probably start that job at daylight on the second or third day and spend most of the day pumping it and rig down that day and the rest of the next day. And that job right there will probably run $450,000 to $500,000. So the customer's going to pay a ticket for about $500,000 on that job. He's already spent, down to here, he's already spent a couple of $1,000,000. So if we add $500,000 onto that, after we get through, he's going to have to go back in here and put a string of tubing in there that he can produce the well through. He's going to spend, before he gets through, probably another $500,000 again. So he's going to have $6 to $7 million tied up in a well, and not a well this size even. And his return on that investment is going to probably be 2.5 to 3 years before he's back to square one. So when you take all of that into consideration, I'm sure you can understand why it's so important that that unit right there be properly maintained. When they sized this job, some of the things they did was they said, well, what's it going to take to treat this well? Well, it's going to take, let's say, 11,500 PSI to frack it. But you'll never reach that pressure if your rate is not right. So what's the rate going to be? Well, the rate's going to have to be 35 barrels a minute. There's 42 gallons in a barrel of fluid. So we're going to pump 35 barrels a minute at 11,500 PSI. Has anybody got a calculator? Well, what we would do is we take this pressure times the rate, divide it by 40.8, and that's how much hydraulic horsepower it would take to fracture this example. And you may find that to be 12 to 18,000 hydraulic horsepower. Well, that's about 80% of brake horsepower, so you're going to have 20,000 horsepower out there at least. And then each one of these things right here will generate about 12 to 1,300 hydraulic horsepower apiece. So you can imagine the money that's tied up in this particular well.
Is that well just deep, or why is there so much quicker?
Yeah, a lot of it is deep, and a lot of it it's a very active area, but to actually get a frac job and get this formation propped open, it takes a humongous amount of sand. Because instead of this well bore being, like I said here, maybe 80 to 100 yards, shoot, this might be a half a mile. So you can see how everything changed. Some other things that changed, you may know a little bit about horizontal drilling. Okay. Let's say this is 130 feet from right there to there. So how thick is your production zone? 130 feet, right? Okay, what happens if you do this? Now how thick is your production zone?
How far can you drill that?
That's right, how far can you go? So you change that from 130 feet to how far you can go. That may be 500 or 600 feet now. So that's what you did to your pay zone. So let's say that this thing was producing 85 barrels a day right here, and we do that, you may well find that this is 280 barrels a day. Now there's a lot of problems with that. What I told you about here a while ago, we can go ahead and cement all of this in like we talked about. Okay? Now how are you going to cement this in? that string of tubing right there, casing, it's very difficult to say the least to get a good cement job on that, but you've got to have one. Because another thing you're going to do now, your preparation you're going to be doing on this, and this really looks different. You know, what I've drawn here actually takes place like that, but the concept is the same. So here you go. Now you've got to shoot holes now for 300 yards instead of 130 feet. So all those costs go up, but certainly production comes up more than just equivalent to it. But the processes are considerably more complicated. So to answer your question, that's how, you know, the areas involved are a lot greater. And a granite formation like you might find in the Elk Cities area would be very tight, very confined. Bottom hole pressure should probably be 10 to 12,000 psi. Most of this stuff here will be 3 to 4, 8,000 maybe max. So it takes, since the pressure's not near as great, your fractures go a lot further, you put a lot more softening. Your production comes a lot bigger. Any other questions there? Some other things that change what happens down here drastically is temperature. You know, you may have a cold formation and you don't put any kind of accelerators or anything in your cement. It's set up real good. Cold takes longer to set up, but it's set up a lot harder. But you might find bottom hole temperatures over 300 degrees. So what happens if the temperature cooks all the water out of the cement? What kind of a cement job do you have?
Chocolate.
So what you have to do is you have to put an accelerator in the cement. So the cement actually set up before the formation dissipates all the water. So there's really a real science behind all of this. It isn't as simple as it seems. Give you a little bit of an idea about some of our equipment. I told you that we have built very little new equipment in the last several years. This is a brand new unit. It's the Peterbilt cab over. It has a 3176 cab under the hood. It's typically this unit will have an 8-speed forward transmission and tandem axle rear ends, and they're more likely than not going to be easy. And this unit weighs about, just like it said, it weighs probably 35,000 pounds. And will haul coil tubing, roll coil tubing on it, or a bunch of treating connections. So you'll notice it's got 15.25 duplex tires on the front. So it's going to be pretty heavy when we get through with it. And it'll probably weigh right at 50,000 pounds, which is about all you can put on a 3-axle truck. Probably in Dow Wilson Lumberjay, I would say that 90% of our tires are tubeless tires, which really does a lot of the tire cost. It's probably the most valuable thing you could do to control tire cost.
What kind of rims you got on?
Say it again.
What kind of rims you running on?
Goodyear mostly, like it would have been an LWD. It's basically the same unit, only a smaller version. Some of the things you're going to see when you work like we do in Oklahoma, Texas, Arkansas, and then we go to Kentucky and West Virginia, a lot of things change in the oil field. And where we've got a location that you can put 18 frac pumps on, they're sitting here fracking a well with trucks on 3 different locations, stringing pipe between them because there's no room up there on the side of the mountain. So the other unit was a cab over, considerably shorter than this unit, and easier to get around on tight locations. This boom here extends to probably 45 or 50 feet. And certainly you can't pull as much out here as you can back here, but like it's setting, it'll lift about 3,000 pounds. Just set it about anywhere you want to set it. And it also has a 3176 cat engine in it. Okay, and then I was telling you about the coil tubing earlier. That's a coil tubing unit, and when you get to the well site, there's going to be a roll of tubing on that spool. As much as 20,000 feet of 7/8 or 1-inch tubing that we could run all the way to the bottom like I talked about and pump nitrogen through. Now, that gets very expensive because that tubing will stand 10 to 12,000 psi pressure. So it is subject to failure. So we've actually got it in the computer and we monitor the times it's been down and bent and straightened because you have to bend it to put it in the well. As you can see on this picture right here, the injector is sitting here on your left. And so the tubing comes off the spool, gets straightened out because it's coming off the spool, goes around the injector so it gets bent again and goes down the hole. So basically that tubing is straight when it goes down through the BOP. So it'll go down however deep we want to go with it. And then naturally when we pull it back out, it gets bent again and straighten again and bend again. So every time you do that, that's a cycle. And so it's only going to do that so many times before it breaks. So we monitor that real close because there's a tremendous cost involved in pulling that out of the well if you drop it. And another thing that happens, that roll of tubing probably weighs 20,000 pounds. So what do you think happens when you get a good percentage of that in the hole? It kind of wants to decide to go down there by itself, don't it? So it takes a pretty elaborate hydraulic and brake system to control the rate on that reel. Because you may only want to go down. And once you reach a certain point, say you had a problem right here, and let's say it's ripped off right there with frac sand. If you hit that bridge, let's say 85 to 100 feet a minute, you're going to corkscrew that tubing plumb up to the top of the well and you'll never get it out. So what you have to do, number one, you got to know how deep you're going. You've got to monitor that tubing down to and including the degree of stretch that it will take place as it goes down the hole and the weight tends to start pulling on it. But when we get that tubing in the hole, what we'll do typically then is use it to blow some nitrogen in there to flush the sand loose. That's a double pump cementer. That unit costs about $400,000, $380,000. It has 2 pumps on it. I don't know that y'all can read that, but that says maximum PSI 10,000. So that fluid in right there will pump up to pressures of 10,000 PSI. And this one's probably in the L-head and will pump about 6,500 PSI. It's got a 3176 under the hood, a 750 Allison married to the engine, a Fabco drop box that switches it from road gear to pump gear because the truck engine runs the front pump when we get to location. On the other side of these square tanks, there's an 8B71 that's also got a 750 married to it that's driving the rear pump. There's a complicated hydraulic system on this thing. There's actually a centrifugal pump there, one right about there on the other side, and a big one back here behind this tub that actually mixes the cement. So we'll use one of them to pick water up, put it in the displacement tanks, use the other one to move the water to the back tub, and then use the big centrifugal to mix it and force feed the troglegs and pump it down the well. That unit will mix slurries up to 18, 19 pounds per gallon and pump it at rates of about up to 12 barrels a minute. Now that's a bobtail unit. We still have quite a few of these in service. This is a float-mounted double pump cementer. Needless to say, the mechanics would rather have this unit. It's a lot easier to work on. Both engines are on the deck. They're both 8B71s. Transmissions, everything are identical. 2 power ends, fluid ends, and so on. And all you do is dolly it down. If you have a problem with the tractor, put another 100. But that isn't as rosy as it seems because some of the problems with float-mounted units, they're long. You don't get them on small locations. And when we get in tighter areas, like up in the Northeast, the wells are considerably smaller, so you don't need 2 pumps. You can pump 5 to 7 barrels a minute. Pressure is not going to be 7,000 pounds. It's going to be more like 2,700. So we go out there with what we call single pump cementer. So if you were in the northeast area of West Virginia, Kentucky, Michigan, Illinois, what you probably find in Dallas Schlumberger is a single pump season just like this one. We have a lot of those in service. And that unit costs right at $300,000. Have y'all seen very much of our stuff on the highway, or nobody? Boy, we're going to have to change the colors, I guess. This is an older unit. It's a blender. So where we were talking about the 18 frac pumps, they will all be supplied by a pump like this. But we'll dump sand into this hopper, mix it in concentrations up to 8 or 9 pounds to the gallon, and pump it with a pump that sits back in there behind where you can't see at about 100 psi, almost 100 barrels a minute. That truck will pump just about 100 barrels a minute. And it's all controlled from this console right here. So when he gets to the location, if you've seen this thing going down the highway, the tub would be folded up back up against here. And when he gets to the location, he lets it down and he actually operates it from there. The truck engine has a transfer case. The truck engine runs the discharge pump, and the deck engine runs the pickup pump, we call it. This typically is a 6V71, and that's an 8V71.
Is that an auto car?
I'm sorry, I didn't hear you.
Is that an auto car truck?
This is a Paystar 5000. They still build a lot of these today. International Harvester still produces this chassis brand new today. It's a real good chassis. A lot of the ready-mix people use that same chassis. In fact, here's a brand new one. That truck right there is brand new and it's built on Paystar 5000 chassis, but it's a brand new chassis. This is a blender also. It's a very complicated unit. It's computer controlled. When we arrive at location and he lets the tub down, he can program this thing to be taken over by a computer in what we call a PCB. And once he does that, he can get out of this house and come down here and grease his valves, change something, or go help Joe lay a line, or whatever he wants to do. This thing will pump 35 barrels a minute down each side. So if the job is less than 35 barrels a minute, that unit is 100% redundant. We can have a total failure on one half of this thing. It's got 2 liquid additive systems, 2 dry powder chemical systems, 2 vortex mixer assemblies. Anything up to 35 barrels a minute, all he has to do is flip a toggle switch. And we're right down the hole with nothing ever happened. But if you want to pump this unit at 70 barrels a minute, that's not true. You couldn't be 100% redundant at 70 barrels a minute. So this thing right here, this is actually a Volvo motor. Y'all worked on any Volvo hydraulic motors? Okay, what about Rexroth? Okay, the truck engine drives a Rexroth pump in the 85 to 100 gallon a minute range, up to 5,000 psi. And the deck engine does likewise. So along with running these mixing assemblies, the truck runs this one and the deck runs this one, we also dump dry powder, and we also blend a lot of liquid additives back in this area here that are hauled, or that are transferred into that stainless steel tank right there. That unit right there, it costs right at $400,000. This is another type of blender. That thing is humongous. When you walk up to that thing, it'll blow your mind. It's road legal, weighs right at 80,000 pounds, hauls almost no product. We haul a little product in these stainless steel tanks. Everything else is blended in these tanks when you get on location. That unit right there, if you can envision the great big frac job that I showed you, the picture of, if you had to go out there 2 days before and blend all the products in those tanks, and then you had a problem with the well, let's say the pulling unit drop the pipe in the hole. And all that product is pre-blended. And that gel's only good for 2 days. You put gel so it'll carry the sand. It makes it real thick, slimy looking. So instead of the sand falling out like it would if you poured sand in a cup of water, it actually retains it in the suspension. The customer would lose all that gel. And that's the bulk of the cost of that job is product cost. This unit right here, we can go to location and actually blend this product while we're doing the job. This thing holds about 200 barrels of fluid. So instead of having 1.5 million barrels of pre-blended product out there to start the job, we start the job with 200 barrels of fluid. We start the job, if we have a problem anywhere, we shut down, and that's all the customer's lost right there for a little bit of products in those tanks. So there's a real advantage to this type of unit. Okay, this is another type of blender. What this does, this has got an axial flow hydraulics motor up here in the top. It's driving a set of huge paddles that are in here. So we can put some slurry fluids in there, gels, waters, diesels, whatever. Dump some dry powder product, which is through a dome that exists out there that you can't see. Turn the little 453 on, it fires a hydraulic system that's turning these motors and sit there and blend that stuff so we get it just to the concentrations we want. And then we shut down and we're ready to pump it down the well. That unit a lot of times will blend the material that goes into this big one. Because you'll go out there with, say, 100 barrels of pre-blended product that'll go to this one that you add the rest of your additives to. Okay, this is a frac pump. So this is one of the units that you see lined up there a while ago where we've seen 18 of them. It has a 3600 KTA series Cummins 3600. Has a twin disc transmission. It's got a torque converter married directly to the engine. Then a drive line into the transmission. And then it's got an OPI power and fluid in pump on the back. And that unit costs about $450,000 to $500,000. The power end, depending on what size fluid end it has on it, can pump pressures up to 15,000 psi. The way you figure that, if you guys familiar with rod load, or even in a Detroit diesel, you know that if you put 2 big injectors in a certain engine, the rod range go out because they can't take that. Basically, that's what you're talking about right here is rod load. You'll take a 3 3/4 inch diameter and square it, pi or square routine, take that times the pressure, and you'll find that if you went through that calculation, you'll find that with 3 3/4 inch power end, at 15,000 psi, the rod load in that engine, that power end is about 190,000 pounds per square inch. So that makes you realize why this stuff is so expensive. A fluid end on that unit costs about $50,000. Just a 3-plunger fluid end. I'll show you this one, then we'll take a break. This unit is basically like the one we just seen. Only if this unit, believe it or not, has been rebuilt, but it has a 2300, a KTA 3600 twin disc transmission. Have you all ever seen one of those transmissions? You cover the twin disc at all here? I'd be surprised if you did. Typically, you'll see these things in a lot of, you've seen the coal trucks where the guy's standing here and the tire's up there. Typically, that's the transmission they use. We tried these in the oil field back in the early 80s, and they're really good. They're very heavy, but we have yet to fail one of these transmissions in North America. We failed several of the torque converters. And I've got some repair cost estimates, and it looks like it costs about $30,000 to repair one if it does fail, so I hope I don't fail any of them. What I was going to tell you though, if you look at this breakdown, kind of there. You can see what the steering axle weighs, what the tandem weighs, what the rear weighs, and the gross is 76,300. What's gross? What would have been gross in Oklahoma several years ago? You know, 80,000. So you could not have gone down the interstate highway with anything weighed over 80,000 pounds on an 18-wheeler. Okay. So you see, we're within just right at 4,000 pounds of being gross now. 5 to 20,000 psi, depending on what fluid is on the machine. Okay, 35 down to 9 barrels per minute, depending on what fluid. 1,400 and 1,500 horsepower. Basically, that goes on to tell you the same stuff I told you all it's not right. That is very obviously not a 16B149. You know what a 16B149 looks like, don't you? That one sitting right out here on the north side of the building. The gray one, the first big engine you see outside. Okay, why don't we take a break there? Let me get our voice back here a little bit. A question, he asked me if this is all I did was run around, you know, and talk to guys like you, and coincidentally, it's not. So I thought I'd tell you a little bit about what I am. There was these two guys sitting in this office one day, and this one was a brand new fella, about like y'all looking for a job. And this other fella, I'm going to call him an older fella, but he was probably a young guy like me, see. So, but he's sitting there at the desk thumbing through this book. So sooner or later, this young fella, his curiosity just, you know how you guys are, just gets the best of you. Just can't keep quiet. He says, what is it you're doing? Are you in here looking for a job? And he says, no, I'm not looking for a job. And he says, well, why aren't you looking for a job? I said, well, I work here. Oh, you work here? Yeah, well, what do you do? Oh, I'm an off-law, he says. You're a what? I'm an off-law. And the young guy says, I don't understand this off-law. He says, you mean to tell me that you're in here looking for a job in an oil field position and you don't even know what an off-law is? And he said, no, sir, I'm sorry, I sure don't. Would you please tell me? And he says, yeah, I'm an old fart with a watch. So that's kind of what I do. But I wanted to get on here a little bit more, and maybe I started this thing a little bit prematurely, but to kind of let you know what I do. I hope I haven't repeated this. I have a tendency to doing this when I speak to several groups at a time, but I did hire out with OSU Okmulgee 27 years ago. And I came out of this school just like y'all are fixing to. The only degree I have is an associate's degree out of this school, just like y'all. I went to work for OSU Okmulgee in 1966, and I worked in Hog, New Mexico for about 13 years. I transferred to Tulsa in engineering. I worked in the engineering department up there in North Utica for 4.5 years, and I've been in this job since 1980. And my responsibility is to manage the shops on that Mid-Continent division. So the one in Ulysses, Perryton, Elk City, El Reno, Enid, and Fort Smith are all my responsibility. Typically in most of those shops we've got anywhere from 3 to 7 people working in the shop, maintaining the fleet. Some of them do special duties like maybe work on the high pressure treating connections that are that we pump through down the well. Those guys usually report it to me directly or indirectly also. OSU Okmulgee, on the bottom of that one slide, I failed to tell you that there's about 1,800 people working in North America in those in those 85 operating areas. And I would take a wild guess and say that about 4% of those are maintenance people. When you see the kind of equipment and everything that I've been showing you on the slides, you can see why we might have a lot more management people, a lot more salesmen, a lot more equipment operators, and so on than we do mechanics. So typically, we have a system in a district where we decide how many maintenance folks we actually need. And we establish that by, we'll take what we call frontline pumper, how many of them are in a district? Well, if there's 12, we figure that each maintenance person can handle 3 frontline pumpers and the related support equipment. So if that's a frac pump, he's going to have a frac pump, a blender, and maybe a flatbed. So coincidentally, in a district that has 12 frac pumps, we're probably going to have 4 mechanics. I guess we'll go ahead and get on into this presentation. And I do want to be sure that we have enough time for you guys to answer some questions, because if you have questions, part of my goal is to get those answered while we're here. So once again, don't hesitate to stop if you've got a question. So that's kind of where we wound up there a minute ago. And that is a Detroit diesel on this particular unit. It's a 149, 16-cylinder 149. And that unit will pump 1,450 hydraulic horsepower any day of the week. That's a fantastic pump right there. The rod load on this power end is like 197,000 pounds per square inch. This is what we call a pressure multiplier. That unit will pump up to pressures up to 22,500 psi. There's not very many of these in service in the world today. Halliburton has a few, DS has a few, and Western Company has a few. But this is a solar gas-powered solar gas turbine, and it's driving some very sophisticated Kelsey Hayes hydraulic pumps that drive these rams. There's 2 rams on the back of this unit that alternate strokes, and it'll pump about 4.5 or 5 barrels a minute. But that unit today, that's a pretty old unit. It would cost over $2 million to build that unit right there today. And consequently, the oil field really can't handle that. Does anyone know what a D348 is? A lot of the D9 cats use that D348 engine. That's what this is a D348. It's a 60-degree vehicular engine that thinks it's a 90-degree engine. And it's really a very good engine. We almost never failed in those. This one was built probably in the late 70s, early 80s, and is very likely still in service today without a failure. And it has an 8,000 Allison transmission sitting right in there, and it has our pump and power engine on it. That's a frac pump also. We talked about if you're in the Northeast, you may not have 40 acres to set a frac job up on. In fact, in a lot of cases, you may not have an area much bigger than this room. It's not uncommon for us to shut the road down on a county road and set our equipment up, all pre-scheduled naturally, set our equipment up on the highway, run the lines to the well and treat the job. That's how tight a lot of those mountains are in Kentucky and West Virginia. So it's real advantageous to have a bobtail unit. That truck right there probably weighs 43, no more than 43,000 pounds. And yet it has 1,400 horsepower, just like the humongous float you just seen. But the problem with this thing, that little lady sitting right in there cost over $500,000. So you can't afford to have a bunch of these things running around. So if that costs $500,000, and this thing runs at 22,000 RPM, so you've got to have a gearbox back here to slow it down. The gearbox costs $50,000. Then this is a 2-speed power engine, so a combination of this power end and fluid end is over $100,000. So you can see why we don't build these today. Because we're going to tie more money up in that unit right there than we will that float-mounted frac pump, twice again as much. But the advantage is there's a horsepower. There's a tremendous amount of horsepower there on a bobtail chassis. So one of the things I was telling in here just a few minutes ago is all of our frac pumps are remote control. So nobody stands on Belleville some of their equipment to operate frac pumps. We stand on our cement pumps, but there's, very little hazard on a cement job. There's a tremendous hazard on a frac job. So the turbine, you just seen the picture of it, this is how we control the turbine. So we'll unstring a cable, a 53 conductor cable, set the panel up in a bus or a TMV, a controlled vehicle, actually turn the master switch on, use the truck engine to start the gas turbine, get it to 15%, turn the fuel on, and hold it until it fires off and runs about 1,000 degrees. And this engine will idle at about 50%. And like I say, it'll run at 110% gas producer speed on that's about 26,000 RPMs. And then we gear it down to 340 RPMs to drive the pump. So you can see the cost involved with that. So you can sit here and actually change your rate simply with a throttle switch, increase your gas producer speed, or engine speed I should be saying. We've got an emergency system, so if you preset wellhead pressure to be 6,000 pounds, and for any reason it goes over 6,000, this thing trips, the transmission goes to neutral and the gas producer comes back to idle speed, and that happens automatically. Then you actually can shift gears, go from low gear to high gear, and do all of that from this panel. Start it, accelerate it, pump it, shut it down. So basically all of our fracturing pumps are built something like this. You're going to operate it from 125 feet away. That's how it happens. So like you're talking about, there's a lot of stuff there that you already know how it works. This is the black box, it calls the brain. When you're dealing with a $500,000 engine, you don't want to take a chance of burning this thing up. This thing is actually scheduling fuel flow. It's how you control temperature in that engine. So if it gets up to 1,155 degrees, it cuts the fuel back. If for any reason the temperature goes to 1,345 degrees, it cuts the primary fuel valve and kills the engine. And then we do reset and start and throttle and decelerate and shift gears and everything through this main J box right there. So it gets a little complicated. One thing it does for DS is it gets our people out of some very hazardous areas. Because a lot of the other oil field service companies on where they're using the pressure multipliers and the pressures are 18 to 20,000 PSI, those guys are standing on the trucks. Blow a line at that kind of pressure, and somebody's really going to get hurt. Now, the rest of this, and there's very little left here, but it gets pretty basic. That's a nitrogen pump. It hauls 3,000 gallons of nitrogen, liquid nitrogen. It's actually pumped as a liquid, pumped through a burner assembly, which takes it about to 80 degrees and makes it a gas. And this unit will pump about 660,000 standard cubic units an hour. So that's a pretty good little rate. It'll pump pressure up to about 15,000. And that's what we were talking about earlier in the picture, a missile we call it. This unit has all of our low pressure piping. So when you come blend the materials in the blender, pump them to the frac pump, it goes through this low pressure side of the pipe, out these ports here to the pump, then the pump pumps right back into it in these high pressure areas to the well. So that line right there will handle up to 15,000 pounds of pressure. And on this particular one, it'll handle rates up to about 30 barrels a minute. And that unit today costs us probably $130,000 to build. Because this piping in here is very, very expensive. That one valve, there's a valve for each one of those stations. That one valve costs about $8,000. Then we don't haul product in these things. This is the sand chute we talked about earlier. We take the location, holds 4,000 pounds of sand. Doesn't say it on there, but it weighs 40,000 pounds. So we'll take it to location and they lower these feet and it sits here and on these feet, so it's very stable. And you actually raise it back into this thing up, lower the belt the rest of the way down, and then you blow sand. That thing will deliver about 13,000 pounds of sand a minute to a blender, which is a lot of sand. And you can't haul product in that thing. It's not designed and built to haul product.
Just sand.
Huh?
Just sand.
Just saying. I was talking a little while ago about control. So this is the control vehicle. When I was talking about the pod blender being computer controlled and the guy can get down out of the cab, he turns the blender over to this section of the pod, which is where the service supervisor and the customer sit. So all their monitoring devices and everything are in this section. The equipment operators are in this section. There's literally 2 rooms in there. The equipment operators have radio communication from the front section to the back, and they have all the monitoring devices that they have in the front section. But the customer doesn't have to hear how the equipment operator's fishing trip went last week. So we kind of isolate these guys. They still have all the communication that they need to do their job based on instructions from the front section. And we treat the well through that vehicle right there. Air conditioned, the customer is in a very comfortable environment, and he's looking at a TV screen.
What do you got when you pull that up on like on the side, and then you just take a wire and plug it in out the other side?
See now, those remote control cables go through here so that the equipment operators, their panel will be set up in here. All the sensors, there's 12 to 15 reels in here that they'll open those doors, those cables are on a reel, and they'll go plug into a downstream densicometer, pressure device, a rate flow meter. So all the data is computed, is brought into the computer in this section. And it also handles a lot of the flow meters. A lot of the flow meters and densicometers are carried on that unit to the well site, and then they're put in a line. We call them sensors. And that unit right there is about over $200,000 just to build that one. I keep coming back to money, but there is a tremendous amount of money involved, both to Dalwell Schlumberger and to the customer. And so I can't overemphasize how important it is that when we hire people to work on stuff, we hire the right guy. That is a PPR. It's a pumping perimeter recorder. And that is the computer system, most of it that you see when we frack a well. So that is all brought into here. He keypads it here. The data all comes into the memory bank, which is on a tape. It also prints a chart. There's 3 monitors also for this system and a plotter printer. So they can plot pressures and rate changes at the well, anything they need to know. And they can also change the program with the keypad if something changes during the job. Okay. So, I'll turn this off and let me get the lights all back on if they're not. What I would like to do now, I would like to take just a few minutes to explain to you guys some things that I feel are important. And maybe you don't, but I can relate to when I was going to school here. I came from a little town in western Oklahoma, and there were like 240 people in that town. There was 8 people in my graduating class. And So the whole school was very small. And in fact, it was reaching a point of almost having to be closed. So when I was in the 8th grade, they put me in a senior English class. So I got 5 years of senior English. So when I came to Okmulgee to go to school, one of the first things I thought about, I want to get through there as quick as I can. So I'm going to test out everything I can. I don't know if you can still do that today or not, can you? Can you test out some things? What can you test out of it?
No, we just did a few, English, all your general ed.
Okay.
That's up to that.
Well, two of the things I found out very quickly was that I could test out English if I passed, and I could test out of welding. I was born and raised on the farm. I had 4 years of FFA, so I could dadgum sure weld. And so I tested out of welding, no problem. I took that English test, and I made 100 on that test. And I was so proud. And believe it or not, the old gal wasn't going to pass me. You know why she wasn't going to pass me? Because this is how I spell diesel. And believe you me, she crucified me for that. She says, I tell you what, for just a little bit, I'd flunk you in a minute, that I dadgum sure can't understand how you can be in a diesel course and not even know how to spell diesel. She did pass me, but I didn't think she was going to. She scared the daylights out of me. So, to me, after that happened, some things like technical report writing, nobody could have ever convinced me that I would have a need for something like technical report writing. Today, I would hate to guess how many reports I have to make every month. And they're all maintenance related. They get down to scheduled and performed. In our inspection program, we got 50 units. We may have 60 or 50 inspections scheduled. We might only get 40 of them done. First thing my boss wants to know, he don't want to know what those numbers are, he wants to know what the percents are. What's your percent? Well, it's 70%. 70% complete or 70% incomplete, you know. So when you start talking about what you need and what you think you need and what you really need, they may not be the same thing. But I think like technical report writing and your English and your math courses are all very important. We go through a budget process every year. Or we hire people based on about 5 different numbers. And believe it or not, one of them is revenue per employee. So I'm allowed so many dollars revenue for every maintenance person in my force. So the first thing I'm going to have to tell my boss is, well, if we're going to run $30 million this year, I ought to be able to have this many people based on this number, revenue per employee. Another thing we do is, like we talked a minute ago about frontline pumpers per amount of mechanics. We figure every mechanic can handle 3 frontline pumps and the related support equipment. So you take all of that into consideration, and the fact that some of those trucks that I just showed you pictures of were not brand new. To be honest, some of them are over 10 years old. So we don't maintain that fleet near as cheap as we do a new truck. So one more time, you've got to be able to calculate percentages. You've got to be able to track equipment cost. All of those things are important. They're very much a part of what I do every day. And if you guys are going to ever do something more than just turn a wrench, you're going to be wanting to do some of those things too. And another thing I always like to talk about just a little bit. This one's a little difficult because it actually involves me, and this is a true story I'm going to tell you. So it's the kind of a thing that, you know, when you're your age, maybe you don't think appearance or attitude or anything is that important, because what you guys are doing today is looking for a job, or maybe in 5 years you're looking for a career. So coincidentally, in the course of your life, some things change. But when I got out of this school, I went to work for International Harvester. And I worked for them 3 years, and I got mad and quit. Because I didn't think I would have to go to the bar and drink every night till 2 o'clock just because everybody else did. So I went up doing all the dirty work. That worked on me for a long time before I did anything about it, but I did finally get up a little backbone and said I had enough and I quit. So I went to work for Dowell Schlumberger, Dowell at that time. And when I hired out, I had no idea what they did. All I knew was they were black and orange. I often wondered if Carolyn put that down there because she knew I was coming here today. But anyway, I did see those black and orange trucks sitting there. I went in there and applied for a job. They said, no, they didn't need anybody, but they called me if they ever did. Well, I got my application back to them, and they seen that I was a graduate OSU, and I had 3 years working on International Harvester trucks, and they hired me the next day. But the night before, they told me they didn't need anybody. But what they did, a guy actually drove up from Midland, Texas the next day, and he said, I was ready for him. But he said, well, I'm going to hire you, got a job for you. He said, I want you to go to work in Midland, Texas, building engines for me. And I told him, well, if you didn't have a job for me in Hobbs, New Mexico, you didn't have a job for me, period. Well, that was one thing that I learned was things change. Because that guy took that for gospel, where would I be working today? I'd still be running the shop in Hobbs, New Mexico. So things do change. But so when you talk to someone, I guess the point behind all that is you're never going to get more than once to make a first impression. So remember that. But after you get in, it's probably equally important. After you go to work for someone, I truthfully believe that the attitude and all the appearance and all that you conduct in your day-to-day work routine has a bearing on what happens to you. So that gets us to the story I'm going to tell you. I worked for that International Harvester for 3 years. So they were gracious enough to let me keep my old cruddy uniforms. So I took them to work with me with DS. And I got up this one morning, and I was about as country as they come, believe me. I wore blue jeans, and I didn't wear a belt. So I always looked like the next step I took, I was going to lose my britches. I might shave once a week if I really thought I needed to bad enough. And I was always clean. I always had a clean uniform on, but this district manager had bought me 6 brand new Dowell uniforms, and they were nice. They were so nice that I didn't want to wear them out. So this one day I'm out in the shop working, and the district manager comes out to the shop, and he just walks around me. And I'm standing right there. He walked around me twice and never said a word. He went to the front office, and he got on the intercom. And over the intercom, he said, Bob Link, you get your hind end to the front office right now. And I thought, oh, brother, what in the world have I done? So I mustered up some mustard, and I went up to the front office. I walked in the door, and he's sitting at his desk. He seen me come in. He had a pretty good sized office. It was about half the size of this room. So I'm standing there, and he got up and he walked around me again. He says, you know something, Link? You are, without a doubt, the scroungiest person I have ever seen. He said, you need a shave. I don't think you've shaved this week, and it's already Thursday. He said, a haircut wouldn't hurt you, but we didn't wear long hair back then, but for sure mine probably was a little long. And he said, look at your dadgum pants. He said, I just about take odds you can lose your britches before you get out of the office. He said, why don't you ever wear a belt? And he said, what happened to those brand new uniforms? I ain't seen you wear a brand new uniform since I gave them to you. What do you think I bought those things for you for? So I thought, you know, I'm history. So I went back out the shop and I went to work. The next morning I came to work and I shaved. I put a belt on. I didn't have the hangover I got, but I kept my pants up anyway with a belt, a brand new uniform, and a clean shave. About 2:30 in the afternoon, lo and hold of this guy, don't come back out there. And he's about this tall, and he walks like this. Boy, he does about 100 miles an hour. So here I am out there working in the shop again, and what's he do? He comes out there and he walks around twice, just like he did the day before. Never said a word. Went up to the front office, got on the intercom, said, Link, get your hind end up here to this office right now. And I'm sitting here, oh my goodness, I can't take another day of this. What did I do now? I walked in his office, he just looked at me, and he slapped an envelope on the table and said, that's what you get for wearing a belt, and he gave me a raise. And that's a true story, that really happened to me. I might have exaggerated that a little bit, but that's almost exactly like it happened. One thing I learned right then, to me, at that point in time, I decided that probably the way I looked had a lot more bearing on what other people thought of me than what I really thought of myself. Because one thing I can very honestly tell you is I have never been afraid to work. I'm probably as hard a working guy as you'll find than I was back then. I was raised on the farm. That was one thing I learned, and he knew that. So he probably seen something in me that I couldn't see in myself. Because in less than 2 years I was running that shop. And in less than another 3, I had the engineering job in Tulsa. And in Dowell Schlumberger today, based on the numbers from 1982, 8 out of 10 people are gone, and I'm still here. So that doesn't say a lot for the oil field industry, but I believe it really does say something for someone that's willing to do the job. Any questions?
Can you give us some kind of idea on insurance benefits and starting pay and things of that nature?
You bet, I'd love to do that. What I'll tell you, most of it's going to be generic, because there are some differences. What we will be talking about mostly is in North America, and even mostly more than that, the division I work in. But some things I can tell you, if someone had an interest in another area, I have all the contacts to get an application or whatever in the hands of the right people. We have people a lot of times want to work overseas. So if we were going through an interviewing process and I had an application in my hand and the guy said he wanted to work in Libya, I'd forward that application to Houston, and there's a better than average chance that application would be reviewed and the person might be hired. We have people working all over the world. I wouldn't go to work in Libya either, but you know what I'm saying. So mostly what we're going to talk about is in North America, entry-level mechanic today would probably go to work in our shop at about $8 an hour. He would get paid straight time only, up to 40 hours, and then overtime over 40 hours. But if he worked less than 40 hours, entry level, he'd only get paid for the hours he worked. So if he worked 35 hours, he'd get paid for 35 hours. Now on the, where I said that the entry level person would assist the mechanic 1, in about 6 months is a normal pace for a person to progress to an entry 1 mechanic, a mechanic 1 position. At that time, you would go into 40-hour guarantee and overtime for all hours over 40 also. So really the only difference in those 2 programs, the entry-level person usually doesn't get paid for 40 hours if he works less than 40 hours. But that doesn't happen very often in our company either, because usually working 40 hours is not a problem. We're pretty short-handed today. We haven't been able to hire a lot of people because we're not making mega bucks like we were back in the 80s. So most people are working 50 to 60 hours. So it'd be that type of situation there would be 40 hours straight time and then overtime for all the hours over 40. We have a very good insurance plan where you pay half, the company pays the other half. My insurance cost me probably $25 a month for myself and my family. And you have some options there that you don't, if you just want yourself insured, you could do that if your wife's working somewhere else and she has her own insurance. That would be something that would save you some money. We have a dental plan, we have a vision plan. I bought 3 pair of glasses this year, a pair of shades, a pair of safety glasses and these. I don't have $30 tied up in the whole program. That includes my examination. If you do a preventative maintenance program on your teeth, like I'd like to see you do on a truck, it doesn't cost you anything. You go in and get your teeth cleaned, get a good checkup. They pay for that. We have a credit union. Typically, they pay an interest rate like the bank does. You can borrow money through there to buy a car. So if you're putting money in there and borrowing money out of there, it's almost like interest-free loan. But like I say, if you don't have any money in there and you borrow money from there, you pay about, I think it's 1% on the unpaid balance, which figures out to be 8.5 or 9% a year. And you can probably do that at the bank, but I think there's a real advantage to belong to the credit union. We've got about 3 different savings plans. One of them, you can buy stock in Schlumberger at 15% below the market value. And if y'all have watched the stock market very much at all, maybe you probably haven't, I didn't when I was your age, but you can do real well on that. You get 15% below market plus on June the 30th, or 1 year later, July the 1st, whichever one of those 2 prices is cheaper, you get a 15% off of that. So you make 15% on your money right up front, right off the bat, and you can't do that anywhere, just about anywhere. Like I said, in North America, we've got the 7 divisions, 47 districts. We've got districts in Bakersfield, California, and Santa Paula, Prudhoe, Fairbanks, Kenai. We've got about 5 districts in Canada: Grand Prairie, Red Deer, Rocky Mountain House, a couple more I can't name, Medicine Hat. Then we've got districts in Williston, North Dakota, Rock Springs, Wyoming, Worland, Wyoming, Casper, Wyoming, Vernal, Utah, then Hobbs, New Mexico, Artesia and Farmington, New Mexico, Midland, Texas, Sonora, Texas, Laredo, Longview, Bryan. So we're all over South Texas, and then all over the Gulf Coast. The Northeast, we're probably as sparsely located in the Northeast as anywhere in the United States. The Western Division, which is the Rocky Mountain Division, is real big. They're quite a ways apart, but there's quite a few districts up there. Where in the Northeast, we've got districts in Michigan. We've got 1 district in Michigan, 1 in Illinois, 2 in West Virginia, 1 in Kentucky. And then you've seen the stuff in Oklahoma, Kansas. So one thing, should I wind up, Carolyn has my address. Even if Mid-Continent Division is not hiring and someone gives her an application, she also has some Dallas Schlumberger applications. And you get that to me. If there's a certain area you're interested in working in, write that on the top of your application. And if it's outside of my area, I'll forward it to the person in charge of that area. Because it's not uncommon for us to find a guy that wants to work in Wyoming or in Colorado or California. And so I can get those applications in the hands of people that need them. Right now, like I say, we're very likely not going to hire anyone in 92 in my area. There's a fair chance we might hire 3 to 4 people in 93. And some of those probably would come out of the spring class. Yes.
Would you have a better chance of getting on if you decided to hire out of state?
I would say you would have a better chance of getting on if you didn't care where you worked. if I got an application sent to my office and it said I'll work anywhere, the first place I'd send it today would be to Laredo, Texas. You've seen the big freight job, and I don't think I need to say anything else, you know why. And the second place, believe it or not, is Glenville, West Virginia, Prestonsburg, Kentucky. Those are real good areas right now too. I don't know if any of y'all have been in that part of the country. It's quite a bit different. You have a question?
I got it. With all these little boys that get these bachelor's degrees that can't find jobs, would you be more apt to hire one of them than a graduate that just come out with an associate's degree?
Okay, it kind of depends on what we're looking for because we hire both people. We hire a lot of PEs, a lot of electrical engineers, quite a few mechanical engineers. Typically, those people go into different jobs. We'll hire those guys that will usually start in the system for a very short period of time as an equipment operator. Keeping in mind that these degree people, 4-year degree people, and they're pretty structured, and their goal is going to be to move up the ladder. So even though they may hire out as an equipment operator, they're probably going to wind up in a service supervisor job or a salesman job in say less than 4 years. Where we hire typically, but you guys got the same growth pattern that those guys do. We hire, most of the people we hire out of this school, we hire for maintenance type jobs. Some of the things I didn't show you, but in our structured career development program, we hire people at entry level, and then you go mechanic 1, 2, 3, 4, 5, 6, 7. Then you wind up in a shop supervisor's job, which is a point level job that will be from 9 to 13 points, and then you would wind up with my job. And as far as I know, I don't know anyone that's got a job like I've got that's typically, that's 20 years. And they're probably as far as they're going to go, which I have no problem with that. It's been really good to me. So if you hired out today as an entry-level person, probably if you were really doing your job in 6 months, you'll probably be a mechanic 1, at which time you'll get a raise. We have a salary review program that for everyone takes place January 1st. So based on your performance, we rate our people A, B, C, D. And the D people usually go out the door if they're a D 2 years in a row. And the A people are our top performers. And so A people get better raises than C people do. You see where I'm coming from. So a very young, aggressive, hard-working person can be an A performer in a year and possibly get 2 raises. Because every time you make a job level improvement, you get a raise. Even though you're reviewed for merit the first of every year. I'd say I was probably 26 years old when I took the shop in Hobbs. And there's quite a few people that are less than 32 running shops for Dallas Lumberjay in North America. And some of these people elect to go overseas. And if they make the statement, they usually wind up overseas in less than a year if they're usually A performers. I have an example is just across the board, this guy that worked for me in December said he'd like to work in Alaska. I said, buddy, don't say it unless you mean it. He said, I mean it. And he was in Alaska in less than a month. And he likes it.
Is there more money overseas?
Typically there is. They pay if they decided what your base salary would be in North America, it would probably be 1.5 times that. But there's some other things to consider. Is they usually pay about 100% of your housing. All your transportation costs are covered. So when you get overseas, about all you spend out of your pocket is your grocery money. And in a lot of cases, there are countries where they can't even pay you over there, so they mail your check back to the United States and it goes in a bank.
Yeah, they have a direct deposit set up. If you had a direct deposit account,
Yeah.
you
greatly. Anywhere.
Can you have it split up? Any amounts that you want sent to your 3 different banks or however?
I would say overseas you could, if you wanted 10%, you wanted to keep your hands on 10% of your salary and send 90 back to the bank, you could probably do something like that. I don't know that to be a fact, but the way the banking system is today, I sure don't see any reason why we couldn't do that. A lot of what I've said here today pertaining to the oil field really sounds like gloom and doom. If you take into consideration that in 1981, oil was at $48 a barrel, and then you consider the fact that it got down to $8 a barrel, and for the last 2 years has teeter-tottered between 16 and 25, with the exception of the blip for the Persian Gulf. I think you'll see that from 1984 to 1992, that there's probably a lot more stability in the oil field than it really looks like. It's just not the growth magnitude that we experienced from 79 to 82. So where Dowell Schlumberger in 1982 in North America alone had over 10,000 people, that's not including Canada. That it did include Alaska, but not Canada. There were over 10,000 people working in North America, the United States. And today, we've got about 1,800, like I showed you on the slide. So that says 8 out of 10 people are gone. If you look at any other number in relation to the oil field, whether it be a production number, a drilling rig number, a revenue dollar, barrels per day, you're going to see all those numbers changed accordingly. So what happened is the oil field in North America sized itself to what there really was there. It became very obvious to all of our political folks that if you can import oil and sell it for $8 a barrel and ship it plumb across the ocean, maybe the right thing to do was not to drill in North America. Now, as you see those numbers start getting up $20, $22, $24 a barrel, then it again becomes cost effective for Amoco and Shell and Texaco to produce oil in North America. I think another thing that always scared most of the people in this country was everyone felt pretty much like we were going to use up everything we had. You know, we're going to drill it all up, it's going to be gone, never to be again. But if you start seeing all of the new areas that they're experimenting and drilling in North America today, there's probably a considerably greater reserve there than anyone thought. And also I think it's pretty evident that probably in the next 20 years, our primary energy source will not be hydrocarbons. It's probably going to be nuclear, natural gas, some of these other things. So I think people are starting to realize that and starting to think that, well, if it's worth $20 a barrel today and no one needs it in the year 2000, maybe the right thing to do is go ahead and drill it up. So next time y'all start driving down the highway and you see a black and orange truck, look and see if it's a DS truck. Anything else? Tell me a little bit about y'all. What are some of your goals? What do you guys want to do? If there's only a few of you really knew who Dowell Schlumberger was today, I've got to believe you have some other plans. What were they? Who were you going to go to work for? You thought about it much?
I can go work for Dar or Halliburton
Okay.
or DS.
How about you? You got any long-range plans? Yeah,
No, I haven't even done any interviews yet. I'm still just kind of listening to different people, see what they have to say before I do any applications.
If I could make a recommendation to every one of you, one thing I would do is I would set some long-range plans. Just kind of decide where you want to be in 10 years. And kind of decide what the price is going to be to be paid for that. And kind of decide what you want to do. Now, I think that the program for you guys is so different from the one that I was in. Today, people change jobs a lot. And when I hired out, the goal was to work for a company 30 years. That's just the way it was. I don't necessarily think that that's the best program today, although I can say that working for Dallas Lumberjay has been great for me. But by the same token, there's so much opportunity out there today. And if you work for a company 2 years and you go to a better job, every time you do that, you've improved your program. And I can tell you that today, Dallas Lumberjay does not look down on a person that has had 5 different jobs. If you can look at that person's schedule and see that every time he moved, there was a tremendous advantage in the move for the person. Simply says that you've got goals, you've got plans. And even if they capitalize on only 3 years of that ambitious, aggressive, let's get up and get it attitude, even Dallas Lumberjay probably wins. And there's always an outside chance that if you're a top performer and you've worked for 3 or 4 different other companies, you get a lot of experience with that, maybe you can keep that guy for 15, 20 years. You never know about that either. Just stay constantly aware of things like you only get once to make that first impression. So even if it's in the hall, if there's somebody standing there in a tie, watch what you say and how you say it, because you never know who the guy may be. And when you get out there in the workplace, you can really develop some very, very positive impressions and never say a word. Never say a word to do it. I mean, you do it in your actions, you do it in the way you attack a problem. If I was going to troubleshoot one of those remote control units today, based on what I know, I would do it 100% different than I would have done it 25 years ago. 25 years ago, I would have developed in my mind what I thought the problem was, and let's just say I thought it was a fuel pump. Off it comes. Lay that scooter on the table and tear it apart. There's a lot better way to do that today. Shoot, we got that pot blender, you turn the switch on, it'll tell you where the problem is. A lot of that stuff has troubleshooting programs built into it. A lot of the computer-controlled engines are going to be that way. So if I did the same thing today, coincidentally, I wouldn't pull a computer-controlled fuel system off the truck, but if I could and tore it apart, it might have cost the company $700 or $800 if they wouldn't have had to spend just because of the real problem, the fuel filter or air filter problem. So if I was troubleshooting a very complicated problem today, I'd probably sit down and start writing notes. Sit down and just right here on a desk pad formulate a troubleshooting chart, a flow chart, whatever you want to call it. Things are that different. You know, we could put a gauge on it and monitor the fuel pressure. Can't do that on 3176, can you? But the computer can. In fact, it'll give you a readout. Some of those things scare the daylights out of me, and shoot, it's just old hat to you guys. You guys are already involved in that stuff, and you guys understand. My kids do more, or did, they're all grown up now, but I do more things on a computer in an hour than I do in a week. If I need a plot run, I don't run it. I couldn't run it. But there's somebody there that can. I know what I need. So I tell her what I need and she does it. But you guys will be doing a lot of that stuff yourself. One of the things that I'm encouraging all of my people to do their own computer input on their preventative schedules. When they sit down and do an inspection, they sit down and input it. At least that way they learn something. I don't spend half my time sitting here at a keyboard when I have trouble using a push-button telephone. Well, that's really all I've got. But I tell you what, I'm here as long as you want me to be here if you've got questions. So don't hesitate to ask for whatever reason. can't answer it, I'll get you the answer, but there's a pretty good chance I can answer it.
How many companies does Dowell operate out of?
Countries? Well, we're all over the world, so if you could see a global picture of the oil field, everywhere there's an oil field. We've got a lot of stuff in Africa. It's broken up into about five areas. We've got a lot of stuff in the North Sea, Aberdeen, Scotland. We've got a huge plant there. We've got about 7 districts in Canada, probably 8 or 10 in Mexico. I'd hate to count how many in South America, Australia. We're all over. At one time we were operating in over 80 countries. I don't know how many that would be today.
So you and Halliburton were in competition with one another.
Right.
So is Halliburton still larger than Dow, or is Dow?
Dowell is probably quite a bit larger than Halliburton, Dowell Schlumberger, because we are a lot more prominent overseas than Halliburton is. In North America, Halliburton is probably a third again bigger than we are. Now, they have done some tremendous downsizing in the last 2 years, where when the market crashed, Dowell Schlumberger, we really took some heavy hits in 84, 5, and 6. So when we were sitting here looking at the marketplace and deciding what was really there and deciding how big we needed to be, we were very aggressive with those moves. Where Halliburton kind of even put out some ads that said, we'll be there. No matter what, we'll be there. Well, they were too for a long time, but it really cost them dearly. And coincidentally, there's a lot of places they're not today. They've closed a lot of districts too. But by the same token, everyone thought 87 would be the tail end of that thing. And if that had been the case, Halliburton would have made a very intelligent decision. It was just a best guess deal. But when the thing continued to slide at 87, I think they finally realized they were going to have to take some drastic measures. But they're still bigger than we are in North America. Dowell Schlumberger has always been perceived as the technical leader, and Halliburton has always been perceived as the muscle, because they were big, huge. And Halliburton they've always had an excellent rapport with their customer. They really do good work. Dowell Schlumberger has always said, finer products, better procedures, new types of equipment. Halliburton, they still stand on most of their pumps to run them today. Well, that does some things for them. One thing it does is it's a lot easier to stand up here and mash a clutch and shift a gear than it is to do it off that remote control panel. So they've got some costs relating to maintenance that probably are not as high as ours are. To say that's good or bad, I can just say that Dowell Schlumberger, if we have a fatality, it's going to be on the highway, it won't be on location. Because we work diligently to keep our people out of those areas, the real hazardous areas. Is that it? Well, I'd like to say I appreciate your time, and more than that, I want to wish you all the best. I think you've made a wise choice in what you're wanting to do, and I think seriously that you can pretty well set your own limits. I think that the way the industry is going today, I am very, very concerned about how we're going to handle the program in 5 years, because enrollment's down. You've seen that. There's not near as many students in class, and that tells me there's not near as many people out there on the job market. But the kind of equipment we're talking about today versus what I worked on when I was your age is so much more complex. It takes more people to do it. So it looks like the available folks to do it's going like this, and the needs are going like this. That's going to be a real plus for you guys, because when you guys get out on the market and you get some experience, you're gonna have somebody say, hey, I want you to come to work for me. You know, I heard about you, I want you to come to work for me. Well, when you do that, that's gonna mean more pay. You're gonna be able to provide a better program for your family. Stand an excellent chance of better educating your children. And so you want to be looking at all of those things. I tell you, I would look at everything that hit me in the face as an opportunity, no matter how tough it was. Just get the program. I think it'll be fine. Thank you.